All right. It's not it. Yeah. So we're going to graph logs, and just as logs are very closely related to exponential functions, the graphs of logs are also related to the graphs of exponentials. So a logarithmic function, that's first two blanks. Logarithmic.
What kind of word is that?
The word we used yesterday? Function, which was y equals log base b of x, is the inverse, y'all remember inverse, of an exponential function. Bless you. Okay, and exponential functions are the y equals b to the x. Yeah.
Respect humanity.
Huh?
It says respect humanity. Oh, humility.
Humility. Okay, inverses. You know what? No, it's good. Okay, inverses are reflected over what line? Y equals x. Those are those kind of bare spots. And remember that the domain and range of inverses are just flip-flopped. Okay, so if we have the domain and the range of the exponential function, then we can just flip-flop those to be the domain and the range of the logarithmic function. Okay, so we're going to use, we've graphed exponential functions before, so we're going to use that to graph our logarithmic. So the way this works is we have y equals log base 2 of x. So this is the inverse of what? This isn't, it's a little different from what we did yesterday. Instead of yesterday, like we would have said that the exponential form is 2 to the y equals x based on that this y is the exponent. Okay, that's not how we use it for the graphing. Okay, we're not doing that. What we're saying, what we're taking today is, that it's the inverse. We're using this relationship that I wrote down up here. Okay, so it's the inverse of, we take the base and then we just put the x right above it. So it's the inverse of y equals 2 to the x. So pretty much all you're doing is like marking out that log and graphing the 2 to the x. Does that make sense? Okay, so this is for the graphing stuff. Just mark out log. It's not there. You don't see it, so y equals 2 to the x. I mean, that's the blank. So we're going to graph y equals 2 to the x. So let's plug in some numbers for x. Let's go 0, 1, 2, 3. If we plug those in for x, what do we get for y? We get 1, 2, 4, and 8. Okay, you're gonna, let's see, how should we make this graph? I'm gonna make my x a little lower and my y-axis to the left. It's almost a straight line. So if I graph those points, so 0, 1, 1, 2, 2, 4, and 3, 8, I see my exponential function. And this one has a horizontal asymptote of what? 0. Yes, y equals 0. Okay, that's the exponential one. You can label it if you need to. The next thing to do is draw that line that we're going to reflect over, the y equals x. Okay, so I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, all the way up. That is, yeah, that's straight line. And now we can just reflect it. So instead of, you can make a table if you need to. Instead of 0, 1, we're going to do 1, 0. Instead of 1, 2, I'm going to do 2, 1. Just reflecting across. Instead of 2, 4, I need 4, 2. Instead of 3, 8, I need 8, 3. So there is my logarithmic base function of log base 2 of x. Now, for that one, it has an asymptote, but what is it? Anybody have a guess? X equals 0. Very good. So is it a horizontal asymptote? No, it's vertical. Okay, it approaches the y-axis, which the equation for that is x equals 0. Sorry, my mouth got stuck. X equals 0. All right, so logarithmic functions have vertical asymptotes.
Wait, where's the line for the axis?
It's the axis right here. So it would approach and approach and approach 0 here, but it'd never actually get to it.
Oh, so just that one, not the other one.
Yeah, the other one's asymptote is the horizontal. Okay, any questions? Okay, as we keep going, now we're just adding in h and k. So we're just going to translate it up and over, left and right, up and down, all that. As usual, h is stuck with x. So it's in the parentheses with x. And k is stuck at the very, very end, right? Okay, so we are going to start with y equals log base 6 of x minus 2 plus 3. So we can see how it moves. We're going to start out graphing the parent function. So the parent function is, we're just going to lose the h and the k. So that would be y equals log base 6 of x. Now, we need to graph that, and it's a little difficult to do. So we're actually going to graph the inverse first. Well, we don't even have to graph it. We're going to make a table out of the inverse, and then we'll just flip-flop the points. So y, or not the inverse. Yeah, the inverse is an exponential. Oh my goodness, my brain. Okay, so we're going to figure out points for this, and then we'll just switch them. So let's see. Let's plug in 0, 1, 2. Let's stop there because it's going to get really high. Okay, if I plug 0 into this, what do I get? 1. Okay, if I plug 1 in, I get 6. If I plug 2 in, I get 36. Okay, that is for the exponential. But for the log, so y equals log base 6 of x, we're going to flip-flop them. So it'll be 1, 0, 6, 1, and 36, 2. Y'all okay if we only graph one of those? Sure. Okay. Like only graph the log instead of graphing this and then reflecting it. We'll just graph this one since we have the points. Okay. Try to get your y-axis as far over as you can. Okay, so this is x, this is y. I need to get all the way to 36. Let's see. I think if I make this one 36, so every block will be 3. So let's see, 6, 12, 18, 24, 30. I'm going to graph my points. So 1, 0. Remember that every tick mark on that is 6. So every block is 3. So going over 1 is just barely going over. It's a third of a box. Okay, and then 6, 1, and 36, 2. And your graph may look a little different than mine, or on your homework, yours might look different than somebody else's, depending on exactly what you did. All right, so we just finished the first step, which was to graph the parent function first, okay? We had to look at the inverse, flip-flop those points, and then we graphed it. Now we're going to find the values of h and k. Okay, so I'm going to use black now. H is right there with x, and k is hanging off the end. So what do those make happen? What did the h cause? Right 2, and then the 3 made it go what? Up 3. Very good. No, we already used that to make the parent function. Yeah. Okay, so we can take each point and move it right 2 and up 3. Remember how your units worked though. Right 2 is not moving it 2 whole blocks. Okay, if I'm moving this one, it was at 1. If I move it right 2, now it's at 3, and I go up 3, 1, 2, 3, so there's my new point. Okay, if you want to map it out on a chart here, just add 2 to the x, so that would be 3. Add 3 to the y, so 3, 3. Add 2 here, add 3 here, so that'd be 8, 4. Add 2, add 3, so 38, 5. Or you can just do it on the graph. So my next point, go right 2, up 3, so that's that 8, 4 right there. And then 38, 5, right 2, up 3. And it shows you. What is the, now it's a vertical asymptote. What do you think the vertical asymptote is going to be? That's what it was for the first one. It was x equals 0 there. What happened to all of our x's?
X equals 2.
They went right 2, so our vertical asymptote is going to be that 2. So it's kind of like this dotted line right here. So our graph approaches that dotted line, but never really gets there. So that is our translated function. So that's log base 6 of x minus 2 all plus 3.
Why did you want us to translate it?
Because the h and the k, the 2 and the 3. So those problems are kind of long, but you only have 2 of them. And then the one at the very end is one of those where you have to think. Okay? So this one goes together and this one goes together. So the blue graph, the first one we did, the vertical asymptote's at 0. The next one, it's at 2. Okay.